Hi, this is Lori, and this is my homework for Paul McWhorter's AI on the Edge class. This is for lesson number 6. In this homework, we've been asked to make a dimmer for our RGB LED. We can pick whichever color we want to use. I'm going to use red. And yeah, it should be a pretty straightforward thing. So we basically have to transform the data we're getting out of our potentiometer, and when we move it and turn it and make that into the amount of brightness we want for our RGB LED. So we'll set everything up as Paul has taught us, and you can see here we got the RGB LED and the ADC, and then you may have noticed that I also imported the median function from the statistics library because I'm going to try to get a little less noise in my potentiometer readings, and I'm going to use a median of 3 values, so that's going to be the middle of those 3. That'll get rid of some outliers as we get, you do tend to get a little bit of outliers, fluctuation on that potentiometer sometimes, probably many reasons I'm sure, but anyways. And then I'm going to also use try and except, so that allows me to do a keyboard interrupt and close out the program gracefully and make sure the LED is turned off when I end the program. And I'm sure Paul's going to talk some more about that in a future lesson. So in my while true loop, I'm going to get my reading from the potentiometer. I'm going to create a readings list. I'm going to populate that readings list. And then I'm going to take the median, and that's the value that I'm going to then transform into a brightness value for our function. So I'm going to use a nonlinear equation because many of us who've been in Paul's classes have learned that we perceive LED brightness in a nonlinear fashion. So just doing a straight linear translation of the potentiometer value to a percent brightness will leave a lot of change in the very beginning as you turn the potentiometer, and then not hardly any change at all as you kind of go from like the halfway point to the upper point. You'll see almost no change in brightness when you do a linear transform. But if you do some sort of nonlinear dimming equation, you can kind of linearize that so that the change is more constant as you move the potentiometer. So that's what I'm trying to do here, and I'll make a link to a homework where I spent a lot of time investigating that. And there's a lot of different kinds of equations you can use to do this. This is one I did the last time in the Pico class. And like I said, if you're interested in learning more about that, you can take a look at that homework. All right, and then we're just going to set the brightness once we make this transform. So you can see I'm using an F, elif, else. I'm a fan of using them. A little bit of a disagreement with Paul there. But if it's less than 10, then I want it to be fully off. If it's greater than 4,000, then I want it to be fully on. Otherwise, I want to do my nonlinear equation. So that's just making sure that when I have it turned all the way off, I'm getting off, and when I turn it all the way on, it's fully bright. Just due to some of the noise in the potentiometer readings. And then we'll just set the brightness, and we'll print those to the shell. And again, I'm using an F string. I talked about them in my last homework lesson. So again, it's a way to format, and you can see I'm formatting the reading that I'm getting, the median reading from the potentiometer, and then what is that percent, and I'm using a justify here. That's what the greater than symbol is, and I'm saying I want 5 spaces with 1 place after the decimal, and it's a float. And this end equals /r just means that it's going to replace, so I'm not going to fill up the shell, it's just going to keep replacing. In fact, you can see it's running right now, this program, and you can see what the output looks like. It has potentiometer reading, and you can see it fluctuates a little bit. Even with the median in there, you get 0, 1, 0, 1, 0, 1. I have it turned all the way off, and the percentage. But you notice now, because of the way I wrote this if, elif, else statement, I'm not getting any fluctuation in the percent that I'm sending to the RGB LED. And let's just go a little bit further. There's the except part of try and except, so that's keyboard interrupt. So Control C will cause this loop to stop, and it will then make sure that that red portion of the RGB LED is off. So that's how it works. So let's get over here and check it out. So I'm gonna get my hand on here. It slides a little bit, and let's turn it on just a little bit, and you can see it just barely come on. And I'm gonna give it some more good juice here, and here we go, going up, going up, going up, going up. I'm full brightness. And I'm going to come back down. Until we get off. There we go. Yeah, so that's my homework. Thank you, Paul, for a great lesson, and thank you for watching.